Okay, we are actually discussing this in the last class so that we can continue this equation and fulfill it, right? I have given the basics on how to do that. I'll also share the entire screen so that I can open the paint window and use it when I need, okay? Let me share the entire screen. So I'll proceed it now. So those who know the answer can say now itself, right? We actually proceeding it. We had a likelihood function, and this f, small f of sigma I is nothing but it is for a single error function, that is sigma I. And capital F is nothing but the entire sigma, that is this sigma value I'm going to find, this entire sigma value I'm going to compute by using capital F. And I also explained you how the log will work here. And instead of this small sigma I'm going to replace it with product of I is equal to 0 to n sigma I, which is nothing but sigma 1 into sigma 2 into dot sigma n. Everything will be coming to it. So if I take product of this, what will come here is nothing but it is very simple. And this 1 by sigma root 2 pi, it is actually a constant. And if I multiply this 1 by sigma root 2 pi, what will come? If I multiply 1 by sigma root 2 pi, what will come? If I multiply 1 by sigma root 2 pi n times, that is 1 by sigma root 2 pi into 1 by sigma root 2 pi into, like that, if I multiply n times, what will come? Can I write it as 1 by sigma root 2 pi the whole square, so whole power n, sorry. Shall I write like this? If I multiply this particular constant alone n times, shall I write like 1 by sigma root 2 pi the whole power n? Similarly, if I put this pi inside the exponent, as yesterday said, when I put exponent inside the product term, this exponent can be considered when I go for a logarithmic term. So this product in exponent becomes plus. So I can write this as exponent of plus sum. So I can write this like with the term, the same, the product I is equal to 1 to n will now become sum. So I just take this and put it here. And instead of product, when it comes inside the exponent term, it becomes sum. Sum I is equal to 1 to n, the same thing I can write. That is minus 2 by sigma squared summation I squared. The same thing I can write. And here also I can make some small adjustment that minus 1 by 2 sigma squared is there. Right? Minus 1 by 2 sigma squared can be taken out of the summation. Why? Because they are constants for that summation. So I can take this here and write this as minus 1 by 2 sigma squared. Similarly, I can write this slash epsilon square.
Yeah.
So this was the term we are getting here. That is 1 by sigma root 2 pi the whole power n exponent of minus 1 by 2 sigma squared. The product term I turned into a summation term, right? So this is the intermediate term when I get this epsilon value. Now I'm going to replace this epsilon value with y minus beta 1 x. So the same equation I copy and come out here. Write it as, instead of this particular epsilon error, I can replace it with y minus slash beta naught 0, beta naught minus beta 1 x1. Why? If I put the epsilon here, if I take beta naught and beta 1 towards the right hand side, I can get y minus beta naught minus beta 1 x, the whole square. I do that, right? So I know this was the final term which I get out of this maximum likelihood by using the normal distribution. Now everything is done. Now I can proceed into the log terms, and I have explained how the log will work in the last class itself. When I take log, what are the things will happen? I explained, right? The same thing we are going to do here. Now, so far so good, right? You understood how to proceed, right? Yes? Yes. So the thing here is, if I want to find a parameter with respect to beta naught, I just derivate with respect to beta naught, partial derivation with respect to beta naught. If I want the parameter estimation with respect to beta 1, I partially derivate with respect to beta 1. Similarly, if I want to derivate with respect to, if I want the parameter estimation for sigma, I partially derivate with respect to sigma or sigma square. So this is what I'm going to do next. Before going for this, instead of this function is actually called as likelihood function. Instead of working with this likelihood function, it will be easy when you work with log likelihood function. So we will be going for the log likelihood function, that is taking log on both sides. So I get something like f star, that is equal to, I get ln f is equal to, now 1 by sigma root 2 pi. That was a case over here. And you can know, right, if I take the ln of this, wow, what will happen? How many times I'll get this? If I get something like x power n, I take log, the whole power n is there. So the n term I can bring this n over the multiplicative side. If I take log of x squared, I can take it as 2 log x. Right, yeah, the power term can come in the middle, and so I can consider this as n log 1 by sigma root 2 pi. That was the case, right? So, and if I take that also, it having some division here, that is log of 1, which is 0, next minus log of sigma root 2 pi. This is what the term I get. So what is the term I get over here is, I explain that over here, I get like 1 by sigma root 2 pi. I get something like 1 by sigma root 2 pi, the whole power n. This is what the term I actually get. Right? So what I will do, I'll take this n common. So if I take log of this, I take the n common and write it as log of the same 1 by sigma root 2 pi, 1 by sigma root 2 pi. Instead of writing it as sigma root 2 pi, I write it as 2 pi whole square root of 2 pi sigma square. I write like this, whole root pi whole root 2 pi sigma square. I write like this, right? So when I take the derivative of this log of a by b, I can write a log of a by b as log a minus log b. I can write like that. So I know that log of 1 is 0, so I remove that and I write like minus log of, I get something like, this is actually nothing but log of 2 pi sigma squared, the whole power minus 1 by 2. I write like 2 pi sigma squared, the whole power minus 1 by 2. This is what the term actually is. So the same thing, I will take this minus 1 by 2 to this here and write like minus 1 by 2 log 2 pi sigma squared, the whole power, or like that will be changing it, right? Or I can also keep it minus over here itself and I take this 1 by 2 alone here. So what I will take is this, I can consider it as minus n is already there. I have here 2, so I came here 2 sigma square. Yes. So I get here minus n by 2 log 2 pi sigma square. That's what I hear. Here I write it as minus 1 by 2 log 2 pi sigma square. This was the term I get here. Right? I use the same term over here. And I have the n already present here, and that n also I can take inside and put here. So this was the whole term I'm going to get. Right? Now I'll go to my Word document and update the same thing over there also. Right, so I have this paint window over here. So the same, this is the thing I get. I just substitute this into my Word document, and I can even further divide this 2 pi sigma squared further. 2 pi sigma squared is actually 2 terms in multiplication. In log, if I have something in multiplication, I can separate this as log 2 pi plus log sigma squared. I can also put that, right? So minus is there inside, so I substitute minus to both. So when I come here, I write this like minus n is common for both the things, minus n by 2. And here I write everything as ln or log. I consider it as log base 10 or ln, right? I ln 2 pi 2 pi sigma squared will be there, and I'm separating that sigma squared also separately. Why? Because I want to estimate with respect to sigma squared once. At that time, this will be a constant. So I'll denote the sigma squared. For sigma squared, it is in multiplication with 2 pi. So when I separate, it becomes addition, right? So minus again n by 2 ln sigma squared. Right, so this is the actually the thing for with respect to 1 by sigma root 2 pi the whole power n. For this alone I'm getting this. Next, the whole term is having an exponent that is exponent of minus 1 by 2 sigma squared sigma, right? Everything is going to be an exponent. That exponent I need to derivate now, right? So that exponent I can write it as here. When I take it in exponent in ln, the exponent will get vanished, and I can just have that minus 1 by 2 sigma squared. The same thing will be coming here. Summation I is equal to 1 to n y minus beta naught minus beta 1 x1 the whole squared. Why? Because when it has an exponent, everything will become a normal thing when I take ln on both sides. So that is the thing. So exactly I write the same thing over here. Minus 1 divided by 2 sigma squared, 1 divided by 2 sigma squared I just copy this summation I is equal to 1. Yes. So this was the term. When I take ln on both sides, I get the term like this. That is minus n by 2 ln 2 pi minus n by 2 ln sigma squared minus 1 by 2 sigma squared summation I is equal to 1 to n y minus beta naught minus beta 1 x1 the whole square. Right. Now I need to estimate the parameters. My first parameter to get estimated is beta naught I need to estimate. Next beta 1 I need to estimate. Next sigma squared I need to estimate. So what I will do, I just take the partial derivation on both sides. So the partial derivation is nothing but I need to take partial derivation with respect to beta naught to estimate the beta naught value. So I'll take partial derivation on partial derivation with respect to beta naught. So this is the first one I'm going to take. So when I take this, I will get f star, or I can write it as the dou function is available here. Let me write it like d as per now. Why? Because dou function is not available here. Let me write it like d, and then I change it as dou when I give this to you, right? So I need to do this dou f star divided by dou with respect to beta naught. I'm going to do beta
Sir, that
naught.
is
So
log
that
f
will
now,
be
sir.
equivalent.
That is log f now, sir.
Yes.
Log f, sir. That is not f star now.
Which one?
Dou of log f.
This
I,
see, this f is there now. I consider this f as ln f, and I consider it as f star.
okay, sir.
This f is there now. Yes, f is considered as ln f, and that is represented as f star.
Okay, sir.
Am I making it clear?
Yes, sir.
Yes. Yes. So d f star divided by df. So I think instead of having like f star, I can have like f something like f cap or something by because it is not coming in the equation term. I like let me have like f dash. So I can so bf dash divided by b beta naught. It will be equivalent to, now I want to derivate. When I respect with respect to beta not derivate, this minus n by 2 ln 2 pi entirely will be a constant, so remove that constant. Minus n by 2 ln sigma squared, it is not having any beta not term, so this is also a constant, eliminate everything. Next, minus 1 by 2 sigma squared into summation I is equal to 1 to n y minus beta naught minus beta 1 x1 the whole square. This is the term what I get here, right? So this whole term is having a beta naught inside. So with respect to this I need to derivate. So where is beta naught here? Beta naught is over here and it is having a power. When I do derivation of x squared, it will become 2x. Similarly, y minus beta naught minus beta 1 x1 the whole squared will become 2 into y minus beta naught minus beta 1 x1. That is the term which will be coming here. The same summation will come. This 2 and this denominator 2 will get cancelled and I'll get something like minus 1 divided by sigma squared minus 1 by sigma square, because this 2 and the derivation of this 2 will be cancelled. 2 into y minus beta naught, the same everything will come. The same thing I will be writing here except the power. Power will not be represented here. Let me copy the entire term and then remove something. This thing I can remove. Yes. This power is also not needed. And that's 1, okay. So y minus beta naught minus beta 1 x1. Next, derivate with respect to beta naught. I need to derivate with respect to beta naught. When I derivate beta naught, I'll get minus 1. So when I derivate beta naught, I get minus 1. So nothing more than that. But when I have this minus 1 again and again to be repeated, I need to do this n time summations. This n time summation, so I don't consider this minus 1. That's okay, because I do the n time addition over it, and surely it will get something a very large minus number. I just omit that number, right? Then I multiply with this also, and I just omit it, right? Next I come forward. Next I partially derivate with respect to beta 1. So now what I'll get is dou f dash divided by dou beta 1 equal to, now when I derivate with respect to beta 1, again minus n by 2 ln 2 pi is a constant, minus n by 2 ln sigma squared is also a constant, and the only thing what will come here is this. But this time I get an extra x item because this beta 1 is there, so that extra one term will be coming over here, right? And here beta naught is actually a single term without any variable, so it gave a constant, but here it is not like that, okay? So it will be coming out. Now I'll take that, the same thing will be coming out again, but with an extra x1 term. This extra x1 term it will be coming out. Why? Because this x1 is there, and as usual in the power term it is not discussed, so the power term will not be considered for the negative, right? Because I am having a square term here, so the negative term vanishes. So next partial with respect to, next time I got the beta naught, beta 1, and next time next is sigma squared. So these terms I need to estimate, so I just partially derivate sigma squared. And now, with respect to sigma squared, I need to do this time I'll get some extra parameters. Why? Because this minus n by 2 ln 2 pi it is not having any sigma squared term, so it will vanish. But minus n by 2 ln sigma squared, it is having a sigma squared term. So I need to act on this sigma squared term. Okay. So now dou partial derivation of dou f dash divided by dou sigma squared is equal to this term will be vanished, but this term minus n by 2 ln sigma square. So it is in the logarithmic term, and I want to take it outside. So when it is in logarithmic term, if I derivate, I can get it in ln sigma square can be written as 1 by sigma square. That's what I'll be doing here, and I'll take that. So it is already having minus n by 2 ln sigma squared. It is there. So I'll take minus n by 2. First is that sigma squared separately. So I'll get minus n divided by already 2 is there, and ln x will become 1 by x when I derivate. So I'll test 1 by x is nothing but 1 by sigma squared. So that term I'll take. Next, I have sigma squared alone is a separate term. Ln sigma squared alone is a separate term. That when derivated will give me if I derivate ln of x squared, it will become ln of 2 ln x. It will be there, and I need to derivate that x squared one more time. So it will become x power 4. So that also will be considered. But this time I don't have any n here, so I'll get 1 divided by 2 sigma power 4, because already the sigma squared when I take the whole power it becomes sigma power 4, right? So this is at a minus n by 2 sigma squared plus 1 by 2 sigma squared. And now I go into term. Now I go into the terms. For this I got this. Next actually from this minus n by 2 ln sigma squared I get minus n by 2 sigma squared minus this 1 by 2 sigma squared. Now it become 1 by 2 sigma power 4, and coming inside I don't this everything is multiplicatory as a constant. So this everything is a multiplicatory constant. So it will be having a same term again. The same term will be proceeded again. So I remove this 1 by 2 sigma squared and this minus. So the same thing will be coming here. This is actually the equation for sigma squared. Now what I have to do, I need to may equalize all these partial derivations equivalent to 0. I need to equalize all this to 0. When I make it equivalent to 0, I can get the value for beta naught, beta 1 and sigma squared. But what is the problem here is I can get beta naught in terms of beta 1 and sigma squared. Similarly, beta 1 will be in terms of beta naught and sigma squared and so on. So 1 will be the term for other. So what we have to find, we need to have at least a unique representation for beta naught, which is not having any supported terms like beta 1 and sigma squared. Let us see when I equate df dash by db naught, what will be happening? We'll be first to see that, right? Make d dou d is nothing but dou f dash divided by dou beta naught equal to 0. So that's what I make first. So when I make further that, what will happen? I'll get here this entire term minus 1 by sigma squared. This I'll take equal to 0. So I make everything equal to 0. Now if I make it equal to 0, minus 1 by sigma squared will go into this term and will become equal to 0. So this will be the 0 now. Next, I can easily proceed. This is I can just make that summation term to go vanished. So if I want to make the summation term to get vanished, what I can do is I can just consider this y. How many times of y? If I want to do a summation here, summation I is equal to 1 to n of y. What will happen? It is actually adding y n times. Similarly, b naught is adding b naught n times, and this is adding b1 x1 n times. So I can just substitute n over each of the terms and get the corresponding values. So I just do minus 1 by sigma squared is will now vanish, and I can just write ny minus n beta naught minus n beta 1 x1. That's what the term what I have. So the same terms we will be doing, and then we will be getting the result, right? It will be equal to 0. Now want to find what will be the beta naught value. For beta naught I need to find, so I take ny and n beta 1 x1 to the other end. So I want to get only beta naught in the other side. So beta naught is equal to, I take all the other terms to the other end, right? So ny on this side will go minus ny. So this term I'll take first. Minus n beta 1 x1 will become n beta 1 x1. N beta 1 x1 minus ny. I'll get like this. This is my positive here will go negative there. Negative here will go positive there, right? Whole divided by n. I'll have the entire term divided by n. This was the term. So I'll get the final beta naught value also here. This beta naught is now nothing but beta. I cancel the n. So I'll take the n common over and then cancel everything. So I'll get beta 1 x1 minus y. So this was the term for the beta naught parameter. For beta naught parameter, I can estimate by using beta 1 x1 minus y. So this beta naught, we know that it is actually a weighted constant without any variable support, the independent variable support. Why? Because we have x naught for that. X naught will be usually taken as 1. Right. So for the weighted constant, that is a biased term, the estimation will be beta 1 x1 minus y. This beta 1 x1 becomes beta I xi when there are more number of independent variables. Here we took only one independent variable, that is beta 1 x1. When there are more number of independent variables, this becomes beta I xi, summation beta I xi, like that it will become, right? So this was the estimation for beta naught, right? So I hope you understood how beta naught come. It may be somewhat more mathematics, but it is actually the thing we need to do in multiple linear regression, right? Am I making it okay, students? Am I
Yes,
making it
sir.
okay?
Continue, sir.
Yes. So now similarly I need to go for beta 1, right? Similarly go to for beta 1. For beta 1 I'm having dou f dash by dou beta 1. So I make dou f dash divided by dou beta 1 equal to 0. So this I will do now. So this time I entirely becomes 0. Is equal to 0 now. Right now I can solve it. Now again the same logic, minus 1 by sigma squared will become vanished because it will go into the reciprocal end and become 0. And summation I is equal to 1 to n y minus beta naught minus beta 1 x1. Here the problem is we are having another x1 value. That is actually the problem. I am having some another x1 value. So that is what the other problem here is. So we need to multiply this x1 inside and then get a result. So, but what will be the another problem claiming here is we are actually yet to find beta naught. Beta naught is actually found with beta 1 value. But here, if I find beta 1, again I will get a representation with respect to beta naught only. Because if I solve for beta 1, again I'll get some result with respect to beta naught only. So which one I have to find will be a very big problem. So what we will be saying is, we will be trying to use the correlation formula, what we used in linear regression, the same we'll be using here for this gradient also. What the correlation says, we say x minus x bar into y minus y bar divided by x minus x bar the whole square. We will be using that correlation formula, right? So how much the x independent variable is going to predict y. We use that formula as a base. Why? Because if I solve this beta 1 like this, surely I cannot substitute it for beta naught and then get to the result. Because here beta naught requires b1 to be obtained, then only beta naught itself can be obtained. If I get beta 1, if I solve for beta 1 here, B naught value will be required. So what is the problem is I want an estimation with respect to x and y only. So what I will do, I will take the correlation formula, taking the correlation formula for gradient weight, right? So grading the correlation formula for gradient, it is nothing but the correlation thing. That is, I will be estimating beta as maybe estimating B. This is a basic formula we'll be using in linear regression. That is sigma x minus x bar. That is x bar is nothing but the mean, and y minus y bar divided by x minus x bar the whole square. This is the correlation formula we'll be using when we need to estimate how this x and y is going to estimate the x is going to be related, and how the x values is going to be related with y. So this is for as a normal single variable. If I want to have the entire variable of thing, I can actually make it sum xi is xi minus x bar divided by the corresponding yi minus y bar divided by xi minus x bar the whole square. So this is the correlation formula which actually recognizes that particular independent variable. If it is for x particular x value, then for it is a weight for the particular x gradient. If I have more number of x values, each x will have its corresponding beta value. So it can be estimated by using the correlation relation itself. Why I'm doing this? We need a relation without any beta naught, beta 1 or sigma squared to be present here. So this is the relation for beta 1 here. So that if I use this relation, then I can easily find what is beta naught. Right? I can easily find what is beta naught. Right, and similarly, if I find beta naught and beta 1, my sigma squared equation, if I make this equal to 0, dou f dash by dou sigma squared equal to 0, in that equation I get both beta naught and beta 1. So this is actually for beta 1, and this I'll substitute here. I can get beta naught also, and finally I can find the sigma squared also. So that is why we use the correlation formula, right? So now going for beta naught, going for sigma squared, make bf dash divided by d, that is dou sigma squared equal to 0. So this now the sigma squared formula entirely becomes 0. This term. I make it entirely 0. So now we need to see here. Here I cannot directly take this 2 sigma squared directly. I can take this 2 sigma squared common, and then I can do some analysis over here. So what will come here is I can take the 1 by 2 sigma squared alone common, and I can have something like minus n plus 1 by 2 sigma squared into summation I is equal to 1, the same terms. So those terms I can use here, and then I can get the values, right? Here, why? Because here an additional term is there that need to be going to the right hand side here. So I need to take that additional term also. So I'll come here. This will become this 1 by 2 sigma power 4. This entire term will come again. Is equal to minus will become plus now here, n divided by 2 sigma squared. Right, now I'm having here as equation, here it is having sigma 2 sigma power 4, here it is 2 sigma squared. So what I do is I can literally reduce this sigma squared option. Also I can divide this 2 sigma squared. Here also I can remove the 2 sigma squared, and I can get the result. right? So I can have like 1 divided by sigma squared. Right, sigma is not. We just remove this sigma squared will now become vanished. Sigma squared into summation. The same entire summation term will be coming here. And on the other end, I have just n value. Right now, I want to find what is sigma squared only. So I take the sigma squared on the right hand and sigma squared and then bring the n down. My sigma squared will now be sigma squared is equal to this entire term will come with respect to 1 by n because sigma squared goes in the right hand side n. So it will become 1 divided by n entire value. So this is actually the value for sigma squared. Sigma squared is equal to 1 by n summation I is equal to 1 to n by minus beta naught minus beta 1 x1 the whole square. Right now I know what is beta naught, what is beta 1, everything. So through which I can estimate sigma squared. Right. So this is actually the completion. So how the values are being updated? What is the beta 1? This beta is nothing but beta 1. Right. How beta 1 is computed, how sigma squared is computed, and how beta naught is computed. Right. So this is what are the parameter estimation for the regressions. Either it is very linear or multiple linear. Right.